Okay. So our last chapter, not very long. It's 4 lessons long. All right. We have 6 classes left in math, including today. So we're a little bit tight in time, but not so much. So I'm thinking we may not do all the quizzes. Just make sure we get through the lesson. So usually we'll assignment, then quiz. We might skip a few of those quizzes, just so we can get through the unit in time. Right? But there will be a chapter test. All right. Not a hard chapter. There's actually only 3 days of new material. Day 4 kind of combines day 1, 2, and 3 together. All right. So this new chapter, it's called trigonometry. That's how this word is pronounced. So write down your name and our block. We're block 1 of day 2. All right. So this chapter is about triangles and the geometry of triangles. That's what the word trigonometry means. The geometry of triangles. And so you're going to be figuring out what are the angles inside of triangles and how long are sides. So that's the geometry part of it. Right? So now, personally, this is one of my more favorite chapters to teach with you guys throughout the year. I think it's one of the most practical ones as well. Right? So if you do any kind of building in your future and stuff like that, lots of stuff uses these triangles. Because if you look at our world, most of the things are squares or rectangles. You break that in half along the diagonal, you get a triangle. And with the relationships you're going to learn today, you can figure out angles, you can figure out sides. So one of my hobbies is usually in the summer times, I build things. So I like doing woodworking. So I'll show you some of the projects I've done where this has come in handy for me. So for example, I think this is like 3 years ago, maybe 4 years ago, I built a patio set. All right. So my kids were getting bigger and more rambunctious, and they were going to break something, and they were going to fall off the deck by pushing chairs. So I built this, right? And my plans for building it are this. So I went online. I wanted something comfortable to sit at, so I figured out what the angle is supposed to be. You want your angle reclined here. You want the seating reclined so your butt gets sucked into the bottom of the seat, so it's nice and comfortable, right? And then I figured out my wife has a hard time with chairs because she's short, so she doesn't like it when her legs are always dangling and stuff like that up in the air. So I figured out the height. So then I figured out all the angles and everything that needs to be, all by breaking it into triangles. Once you break it into triangles, you can figure out how long things are supposed to be, what angles are supposed to be, and a lot of construction sort of done like that. So you can do that, and like here is all the pieces. This is one of the biggest projects that I had, so I broke everything in pieces, so I made it all and put it all together. That was my patio set, right? But even if you don't do that, just even everyday things. Like, for example, this is my baby's. A couple of years ago, we were building a fort, and my father-in-law was helping me, and we were getting to the building the roof portion of it. So you have a metal roof on it, the angles that are lean. And my father-in-law's like, hey, let's just climb up there with a circular saw and just cut it to the angle. I didn't feel climbing. This is probably like 14 feet up in the air. I didn't feel like climbing a ladder 14 feet up in the air using a power tool up there. So within seconds on the ground, I calculated what angle is supposed to be just by the distances. We just used the saw on the ground. We went up there and screwed it together. So the stuff we're doing in this chapter, very practical, can come in handy a lot for you guys when you get a little bit older and you have your own place. Because chances are you're going to do something. You can build a shed. You can build something for your kids, right? You can do something, right? And this will come in handy. So to do this stuff, we need to use a calculator. So on your calculator, you need to have 3 buttons. I mentioned this in September. A sin, a cos, a tan. We're not going to use it today. Well, next class on Friday, we are going to use it. So if your calculator doesn't have these 3 buttons on it, usually right in the middle, you're going to have some troubles this chapter. Right? And if you do need to get a new calculator, it's about a $10 to $12 calculator. Right? If you don't have a button that does that. And you'll need this for next year. So if you don't have it, it's not a wasted purchase. You'll need that anyways for grade 10. Doesn't matter which math you're going into, you'll need it. Okay? So today, we're not going to be using our calculator, but we'll be learning how to set up equations. All right? So before we can set up equations, we need to be able to label sides of a triangle. You learned one side name last year. That was the longest side of the triangle, which is over here. It's across from the 90 degrees, and I heard somebody say it, hypotenuse. So the longest side is called hypotenuse, HYPOTENUSE. And I'll just write down on my diagram HYP. Now you'll notice that there are letters on each corner of the triangle. They are put there on purpose so we can reference them when we're talking about sides or angles. So if I want to talk about the side that's the hypotenuse, I say it's side AB. The side between the letters A and B. And when we talk about it, we don't say BA, we say AB. We say it in alphabetical order. So that's just the math convention. I'm not going to mark you wrong if you would say BA, but AB is the correct way, alphabetical order. Okay, now there are 2 other sides. In grade 8, the other sides of the triangle, you call them legs for when you use Pythagoras. Now, with Pythagoras, it didn't matter if you mixed up the sides A and B, but in this unit, it does. Okay. Now, there's 2 other sides. One's called opposite. The other one's called adjacent. And how you label them on the triangle really depends on which angle you're trying to do your calculations with. So here, if I'm working with this angle here, so this corner of the triangle, I'm going to do all my calculations for this. The adjacent side is the side that's next to it. So if you label your hypotenuse first, you have this side and this side. Well, this one's right next to it because that one's opposite. Sorry, that one's hypotenuse. So this side is your adjacent, the one right next to your angle that you're working with. So the side next to the angle is called adjacent. ADJACENT. So on this diagram, that's the side BC. So I write down ADJ there on the diagram. That's okay. And finally, the last side, the opposite, the one across from the angle that you're working with. That's called the opposite. Okay, and that is side AC on this diagram, and we'll just write down OPP on our diagram. So 3 sides. Label your hypotenuse first. The other 2 sides are adjacent and opposite. Okay. All right. So let's work with these. Let's practice here. So my angle in question is right here. We're going on the right side of the page. First off, what side is your hypotenuse? Is it LM, MN, or LN? LN. That's okay. The longest side, and it's really easy to tell from the box. The box always points to the hypotenuse. So HYP. Okay. Now the trickier ones. Adjacent and hypotenuse. Let's do adjacent first. Gavin?
Adjacent is ML or LM?
Yeah, ML. ML or LM, this one right next to it. Here's my angle. There's 2 sides, this one and this one, now right next to it. This one's the hypotenuse. That means this one is the adjacent. So we have adjacent. Therefore, the one across from it is your opposite. Okay? Now, going on to the next one. Here is x. Start off with hypotenuse. What side is your hypotenuse? Caitlin. UT. Right? We're going to go hypotenuse here. HYP. Now, opposite and adjacent. Let's do adjacent first. Pepper.
ST.
Adjacent is not ST. So Gavin?
US.
US. Here's my angle. I want the line right next to it. So here's the line right next to it. Adjacent. And that it would be right there. Therefore, the last side is opposite. Okay. So once you can label the sides of the triangle, you can start using the formulas that connect angles and sides together. Now there's 3 formulas, right, that connect the angles and sides together are these ones here. We have this one that says sin. This is pronounced sine, the shorthand. This little circle with a line through it, it's a Greek letter theta. So this is sine of my angle is equal to opposite side over hypotenuse side. So it sets up a fraction. The cosine of my angle is the adjacent side over the hypotenuse side. And finally, the tangent, that's how you pronounce the last one, of my angle is the opposite side over the adjacent side. So long as you can label the triangle opposite, adjacent, and hypotenuse, you can set up these formulas. Right? You don't need to memorize these. These will be always given to you. I've already written up on the board, and they're going to live here for the rest of this school year. Okay? Now, you will have them memorized, though. You don't need to memorize them, but you will have them memorized. There is this mnemonic there. It's pronounced Sakatoa. And it's one of those things that just gets stuck in your heads as an adult. It's one of the few things you'll remember from grade 9. I was crossing the border a couple of years ago. And when you go across the border, sometimes they ask you a few questions to kind of verify who you are. So I was going into the US, the border guard goes, "Oh, hello, Mr. Dhaliwal. What do you do for a living?" I told him I'm a teacher. Right? And he's like, "Oh, what subjects do you teach?" And he goes, "I go to math and chemistry." That's what I taught at that time. And the only thing he could ask for me, because he didn't remember much of this stuff before, is the word Sakatoa. He goes, "Sakatoa." I'm like, "Yeah, I remember that." And he sort of just, "Okay, let me go." It's one of those things. You go home, you say this to your parents, chances are they're probably going to remember this. So now, the way this works is these are the 3 equations. My sine formula is my opposite side, maybe I'll do in green, orange, over my hypotenuse side. My cosine formula is my adjacent side over my hypotenuse side. My tangent formula is my opposite side over the adjacent side. If you look at the arrows, they just go up, down, up, down, up, down each time. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Okay. So just up, down, down. It will get stuck in your head. We'll be using it every single day for the next 2 weeks. Okay, so let's put this to work. So we're going to create the 3 trigonometry formulas for this triangle and this angle here. So for my angle x here, first off, we're going to label the sides of the triangle. Opposite, adjacent, and hypotenuse. Start off with the hypotenuse first. Is it the 5, 12, or the 13th? Gavin?
It is 13.
13. So this is my hypotenuse. Instead of writing HYP, let's just shorten it even further. Just the letter H. Right? Now, adjacent side. 5 or 12, Caitlin? 12. So I can give it an A. And that means this is my opposite side. Okay? So now, we're going to figure out the 3 formulas. So you go, the sine of my angle, and we don't write down theta this time because our angle is denoted with the letter x here. So sine of x is used for the angle here. And it says opposite over hypotenuse. That is the formula you're given. So we set it up. The sine of my angle is my opposite side on the top. So that's the 5 on the top and 13 on the bottom. 5 over 13. Okay? That's your formula. Now we do cosine of my angle, according to the formula, adjacent over hypotenuse. Okay? So cosine of my angle, what number goes on the top? What number goes on the bottom? How would it be? Let's zoom out a little bit. Gavin?
It would be 12 over 5.
Not 12 over 5.
12 over 13.
12 over 13.
Oh, yes.
Right? So 12 over hypotenuse, my hypotenuse is 13. So 12 over 13. So my cosine formula is set up. All right? Next up. Tan of my angle is opposite over adjacent according to the formula. You do not need to remember that, but we need to set up the fraction. What are the two numbers? What's on the top? What's on the bottom? Remember.
5 over 12.
5 over 12. That would be correct. Okay. So today, we're not learning how to use the equation. We're not learning how to use our calculator. All we're learning is how to set up the equation. And over the next 2 classes, day 2 and day 3, we learn how to use it. There's 2 different ways we use it. Okay? So let's go over here. We're not going to do the bottom triangle here. We're going to do this one here. All right? Let's label it together, then I'll have you set up the 3 equations. What is your hypotenuse? Is it 16, 34, or 30? Which one's your hypotenuse? 34. The longest one. All right? Draw. Okay. What's your adjacent side? 16 or 30? Caitlin?
16.
Yeah. The side that is next to my angle, here's my angle. Here's the side that's next to it. This hypotenuse is already taken up. That means this is opposite. Okay? Now you can flip them back and forth between the first page and the second page and set up the 3 fractions, or you can look up on the board. I have the 3 equations written there. So set up the 3 formulas. Give you guys a couple of seconds here. All right? All right. So now fill in the numbers. Oh, so much. No, you fill in the numbers. Not just the equation, fill in the numbers. Right? Sorry, guess I wasn't clear. Put in the numbers, not just the equations. Nicely done. Good. You adjusting? Okay. All right. Wyatt, wait until we do the next one. All right, then you can go. Okay, let's quickly go through here. Sine, what's your formula? Pepper, what are your 2 numbers?
34.
Sorry? 30 over 34. Correct. Opposite over hypotenuse. Cosine, what do we have? Gavin,
16 over 24.
16 over 34. Adjacent over hypotenuse. Finally, last one. Tan, what do we have as our formula? Pavitra?
30 over 16.
30 over 16, correct. Okay, so we're not going to do the one below this, but I want to do this question here. Okay, so this question here, looking ahead, is asking us to set up the formulas just like we did before, but for two different angles in the triangle. It asks for angle x and angle y. Well, when we label the sides of the triangle, the naming depends on which angle we're looking at. So to do this, when you're given a question like this, just do the same angle once, because you're going to have to label all the sides of the triangle. Then you have to re-label it for the second angle. So we'll do angle x first. And I go, okay, I'm looking at angle x here. According to angle x, what's my hypotenuse? 5, 4, or 3? Caitlin, 5. Hypotenuse, h. What's my adjacent side? Sorry, 4, yeah, and there we go. And that means this is our opposite. So our sine formula then is what fraction? The formula's up in there, opposite of our hypotenuse. What do we have? 3 over 5, thank you. Our cosine formula, and it's adjacent over hypotenuse, so that is going to be 4 over 5. Okay, so now if we go to do the y, we need to relabel. Our hypotenuse doesn't change. The hypotenuse is the longest side, but the opposite adjacent changes. Because what side is now the adjacent side to angle y? Is it the 4 or is it the 3? The 3. Because the side that's next to angle y, if we're talking about angle y now, is angle 3. The side 3. So it's not here. Now this is my adjacent side. And this is now my opposite side. Right? Because the naming of the triangle depends on which angle you're using in your calculations. Right? So you just can't just label it once and be done with. Okay. So now, if you want to do sine of angle y this time, what's my fraction? What's on the top? What's on the bottom? Did it stump you guys? Captain?
4 over 5.
Yeah, our formula is opposite of our hypotenuse. Now the opposite side is the 4. Our hypotenuse is the 5. Okay. Yes, Gavin?
So in the next one, we do 3 over 5.
3 over 5. No, no. It's asking for tan this time.
Oh, okay.
Tan. So what would the tan be this time?
Oh,
Yes?
4 over 3.
4 over 3. Opposite over adjacent. And that's it. Okay, we got like